Welcome to Silicon Valley Education Foundation's Techie Tuesday with Roberta Love. We're figuring out our logistics, so sit tight. So Roberta, can you present so that they can't see your whole desktop? Is that possible? If not, it's all right.
Absolutely. So right now I'm presenting mode, and somehow this is what we get.
No,
Is that fine?
I think that's fine.
Okay. Good afternoon, everybody. My name is Roberta Love. I know I have a strong accent. I'm Italian. So please ask me to repeat if anything. And today my presentation is going to be, what should you do if no one laughs at your chemistry jokes? And thank you for the Silicon Valley Education Foundation for giving me this opportunity. This is going to be an interactive presentation, but before we do that, some housekeeping. Please turn off your camera. So if you're using this platform, you will see this icon. So please click that until it becomes red. Please also mute yourself. It's to avoid any background noises. It's not that we don't want to hear from you. So in that case, you'll tap on the mic icon until it becomes red. And if you had any questions, if you want to express any idea, any opinion, give any feedback, just type them in the chat box of this platform. Or as I said, today I'm going to present with an interactive presentation. To join this presentation, I'm going to put the link in the chat. So you can copy this link and then you can enter the code that I'm copying right now. Or simply go to thepeertech.com/join and you will be able to join the presentation right away. So let's see. I should see some students join this presentation as soon as you log in.
And everyone, a reminder to please turn off your video so that we see Roberta when she's presenting.
So I'm wondering if anybody is joining the presentation. If you joined the presentation through the Peer Deck feature, can you please let us know in the chat? It's either on Facebook or here on the WebEx platform. Yes, okay. Okay, please bear with me. This is new. Okay, let's see how it goes. All right, here's my chemistry joke for today. Why can you never trust atoms? Can you please type your responses? Oh, I'm seeing live the responses. This is great. I heard they make up everything. Oh, that's a good one. Wow. They make up everything. Oh, wow. Where did you hear all these chemistry jokes? Can you please type them in the chat? I thought I was doing something new, but you guys are doing great. Okay, everybody knew this joke. Okay, failed experiment. Wow, you were fast. Great, and I'm glad that the feature of this presentation works great. So here's another little game, fun facts about me. So I'll tell you a fact and you'll show your responses on this app by choosing the option true or false. So first fun fact, I travel in many parts of the world. In fact, I have traveled to all the places in blue here on the map. True or false? Go ahead and type your responses. See 12, 13 responses. Wow, all of you basically are saying true. We have 14 true so far, 1 false. Ooh, numbers are increasing. I'll wait a few more seconds. All right. Somebody's changing their minds. I see jumping between true and false. There is no right or wrong answer, but incorrect. It was false. I didn't travel in so many places, but I did travel quite a few. I am European. I've been mostly in Europe. I've been in the US. I now live here in the US, in California. I was in South Africa once, but not that many. All right, let's see. Fun fact number 2. I know how to skateboard. True or false? Type your answers. We have 8 true, 3 false so far. Thank you for participating so actively. This is lovely. Okay, we have 9 true and 4 false. Yes, I do know how to skateboard. Sometimes I fall down, but it's still an ongoing process. Fun fact number 3. I have worked with reptiles. True or false? Ooh, this poll is going fast. Ooh. 7 true and 5 false. I'll get that. Yes, I have briefly worked with reptiles for the Junior Museum in Palo Alto. It has been amazing, and one of my best reptile is Azul that I couldn't show here because I have no picture of him, but it has been amazing. Okay, last fact, and then we move into more serious topic. I have made explosives in my career. Is it true or false? Ooh, 8 truths and 9 and 3 false. All right. Wow, this is so exciting. All right, so the majority of you say true. Well, it is false. I have not made explosives, but I assure you, I've caused little explosions in my chemistry lab. And that's what I would like to talk to you today about. So, when I was in school, I like math, but I hated it. I was bored most of the time. And I was always considered like the black sheep among all the white sheep. Like, yeah, she's a weirdo. She's by herself all the time. She likes math. What's so weird about that, right? And I spent most of the time playing volleyball. In fact, I train a lot, few hours per day. And I didn't even consider the possibility of going to university. But education has provided me with many opportunities. So what did I do? When I was 19, I was living with my family in Italy and I didn't know what to do with my life. And I chose to enroll to the university and to study chemistry. And the only reason for that, it was like, chemist is an emerging role. I should make a lot of money out of that. And here I was, enrolled at the University of Ferrara in Italy. Ferrara, not to be confused with Ferrari. That's not where the Ferrari car comes from. But so here's a picture of my university. It's a beautiful city. It's a beautiful university, and it's full of medieval buildings. And of course, as I'm Italian, a picture of one of the most characteristic food of the city, which is pumpkin tortelloni. So this filled pasta. In my career, I studied chemistry, and for me, it was quite obvious to go from my master's degree into being a researcher. And I was particularly interested in studying solar cells. So the most common solar cells that we have right now, the commercial one, are made out of silicon. So here in the periodic table, you can see where the silicon lies at, just right beneath carbon. And in the picture, you can see a commercial solar cell made out of silicon. And then we have other two pictures here. And this, by the way, this man on the left in the picture was one of my professor, amazing, crazy guy. So I was interested in that as silicon, although it's quite used, it still has some limits. So, and I'm talking about like almost 10 years ago when I studied, I wanted to explore new kind of materials as this one that we see in the second picture and the one that we see in the third picture. And that's what I was more interested in. So maybe some of you are already familiar of how a solar cell works. But let's say that microscopically in a laboratory, when we make a solar cell, is not as big as the ones that we see on our rooftops. So here is how it works. The light comes from the top, and that's where we shine light from. We have on the top one tiny thin layer beneath which we have what's called an active layer. And on the bottom, just beneath the active layer, we have another layer which is made of a continuous film. By attaching two electrodes on the very last layer and on the very first layer, we generate current. So as a principle, the sunlight shine into the solar cells, it goes through all these layers, and that's how we generate current. My job as a chemist was to study and to synthesize different types of active layers. And that's what I did. So if you want to charge your phone, here is a question for you. If you want to charge your phone, what do you need? And what about if you want to charge a laptop? What do you need? You can type your answer in the chat if you want. Oh, I heard a noise. Do we have anything in the chat? Electrons. Yes, a source of electricity. Correct. So, well, we definitely need the cable. And we need the source of electricity. That's right. And yes, we need cathodes. We need positive and negative electrodes, so cathodes and anodes. I like your answer. Wow, you're amazing. In a solar cells, what we really need, if we're physically speaking about solar cells, we need a push, something that is pushing electricity around, because electricity is just charges that are moving around. Yes, we need a push, which we identify as voltage. And then we need a flow of charged particles. And this flow of charged particles give us the current. So remember, if we want to charge a phone, we only need maybe a small push and a small flow. But if we want to charge a laptop, we need a bigger push, definitely a bigger push and a bigger flow. So in physics, the power of a solar cell is the product between the voltage times the current. And the goal of my science research project was to have a material, that active layer, that would absorb plenty of light. You want to catch all that sun that we have here in California. And we wanted also something that would give us the highest power possible. So highest voltage and highest current. Are you ready? So here is the chemistry part. So I work on perovskite. Perovskite have this molecular formula: CH3NH3 PBX3. C stays for carbon, H for hydrogen, N for nitrogen, Pb for lead, and X is one of these three atoms in the periodic table: chlorine, bromine, iodine. So it's a very complex structure, actually, and we see a picture right here. Why do you think I put an X here and I say that I actually substitute this X with these three types of atoms? What do you notice about the periodic table? And I see two responses coming in. X is definitely my variable. I like that. Remember, there are no right or wrong answer. We're just having a little chat. They're in a column. Yes. I really like what you're writing. Same amount of valence electron. Yes, that's amazing. You know a lot. Same number of valence electron. The periodic table is separated into periods, yes, and groups. So in this case, yeah, I love that. Thank you all for your answer. So in this case, these three atoms are in the same group, or if you wish, in the same column. So I thought, okay, maybe if I change little by little one of these atoms per time, I could actually have some kind of pattern in the properties of the material. And indeed I did. So I got very much different colors, and different colors mean something. So you see the one that have only bromine, Br, are kind of yellowish, and the other ones are kind of dark black. So different colors in chemistry and physics mean different fingerprints. So if we have an electron here, and that's what happened for any kind of material, because electrons are in any kind of material. When we have an electron and we give some energy, in our case, the energy is given by the sunlight, this electron then it moves right up to the next energy level. Right here, the energy level, when it's high, this electron is unstable and it's kind of going around and it's wobbly, and then it falls back on the lower energy state. We can measure this amount of energy by what's called a spectrophotometer. And here we see what kind of pattern we have. So each line represents a pattern for an electron, and each atom has a characteristic pattern. So we can identify different kind of structure of our molecule. I also did an X-ray investigation because these materials are actually crystals. So when you shine X-ray that we commonly use when we break a bone, for instance, or when we go to the dentist, when we shine X-ray through a crystal, we have a pattern that we can reconstruct, and we get information about the crystalline structure of our molecules and of our crystals. So that's amazing. And here is a picture on the left of a very nice clear X-ray structure. And on the right, it's what really my structure looked like. A mess, to be honest. Then we did a morphology investigation, which is through a microscope. It's an electron microscope. Through this gun, we basically fire some electrons on a sample that is inside, and then we collect some images. So this is what my sample looked like. And it's beautiful. I was so in love with this picture that I started to collect all kinds of pictures. So you see here, by playing with different things like changing temperature, changing pressure, changing humidity, changing the liquid, the solvent I was using, I create all different kind of patterns, and I love it. However, here is the saddest part of the presentation, and I would like to ask you, what factors would you consider important for your career choice? Go ahead and type your answer, please. Some responses already. I like it. Pay something you like. Location. Passions. How I would have to work-life balance, enjoyment, financial stability, co-workers, flexibility, not having to sit in one place all day. Yeah, I feel you, especially right now we're home. Enjoying it, your interest, what pays you well, convenience of the job. Would like to go into a tech or business job. If you like it, pay, environment, well, salary and enjoyment, interest. You figured it out already. It took me like almost 30 years to figure it out, but thank you for your replies. So definitely, I would say hobbies, what you excel in. Don't hide. If you're good at something, use it. That's great. Everybody's a good at something. Work style. I couldn't work all day in a laboratory at one point. I couldn't. I wanted to have some social life as well. And also, I wanted to grow. I wanted to still explore the possibilities. And that's why I ended up being actually a science teacher. So I've been a science teacher since 3 years, and I teach at middle school and high school level, and I really like it. I never give up my passion for science. My passion for science is still there, and I'm sure that I bring this passion into the classroom. Here's my takeaway for today. And yes, you guessed the dog right. Why can you never trust atoms? Because they make up everything. And so almost every day when I teach science, I try to make my students smile because it's important to them and to me. And I try to bring into the classroom a science joke. And I love it. For today, my takeaways: choices are reversible. If you start with one career like I did, I was a scientist, I was a researcher, don't be afraid to change your position. Nobody is going to look bad at you. It takes courage, but choices are reversible. Be honest with yourself. If you don't like what you're doing, don't be afraid. Of course, consider your financial stability. Of course, consider all the options, but be honest with yourself. Compromise. it's not always everything black or white, you know. Sometimes we can find compromises in our jobs. And I found mine. I found that I can be a good scientist by sharing my science knowledge with my students. And that's great. Be kind to yourself. We are teachers, learners, friends, sons, daughters, all together. When we go to school, when we go to our jobs, it's not that we say like, oh, now I'm a student, I'm forgetting whatever happens at home or whatever happens at work. It's not real like that. We are all together, all of these all together, and we should take that into account when we choose our career as well. So with this, I finished my presentation and I thank you very much. And I'm open for any questions or comments. You can type them in this peer deck slide or in the chat. Thank you for the feedback. I'm so happy that somebody else likes to tell chemistry jokes. But again, no reaction. That's a good one. I don't know who you are, but I like that. Oh, thank you for your feedback. Yeah, science jokes are the best. They really put me up in a good mood. And isn't that funny that like only science people can understand them more or less? So you guys are on top of this already.
Roberta, I have a question for you.
Absolutely.
How do you think your experience working in industry has...
That's a great question. Um, so I think I can bring into the classroom the the research and industry experience. So I can actually relate what we study in the classroom to real life application. Like solar cells, for instance, there is a lot of science behind it, science and engineer. And it's great when we can explain that through the science that we see every day in a classroom.
Awesome, thank you.
Thank you. Ooh, I like science jokes, but only periodically. I like that. For the so I'm seeing a question. For the solar research, how do you store the extra energy in off-peak hours? And in peak hours, will the power grid have to make up for it? Too many batteries will just cancel out the positive effects on the solar because all the lithium ion will be bad. Yes, I'll wait for you to finish typing. I see you're still typing something, and then I'll reply to that.
Obviously, cable.
I hope the question is clear for everybody, but I reiterate that. Um, so if we have extra energy when we use solar panels, how do we store that extra energy? We'll need to have a power grid that makes up for it. And this person rightly say we cannot just use too many batteries because otherwise we'll counteract the positive effects on that we have from the solar cells. And that's a great question. So we do not so the solar power is a renewable energy and it's not constant because the weather is not constant, right? We have some sunny days, but like today we have a gray day, and then we have day and the night. So what we have is that we do need to store this energy somehow, and we need to release it slowly when we need it. And that's actually a part that research is still working on. Yes, solid state batteries. That's a very nice topic. Um, and that's actually what I work solid state batteries. And yes, they have a lot of positive aspects. I wouldn't necessarily say they have a lower environmental effect, but they show great promises. So yeah, keep up with I mean, sorry about that. Keep up with the good knowledge about it. Um, and yes, they're not ready yet. We're still trying to figure out so many things about solid state batteries. But we're working on that, and there is definitely a huge field on science about this. And I hope you reply your answer, your question. Sorry, not your answer. um, any other questions? Do we have any other questions?
I think that might be it.
All right.
Presentation, and thank you all for joining in. Check in next week where we'll have another guest for Techie Tuesday with Silicon Valley Education Foundation. Have a great one, everybody.